Alright, algebra, I had so much fun making that first video. I thought I'd make you guys a second one that again is designed to give you a big picture overview of everything we've done over the last couple of days covering linear functions. So consider this video notes. I'm going to start by putting this equation into standard form. By adding 12 to both sides, I get 3x minus 6y equals 12. This is standard form, because I've got a number times x plus a number times y equal to a number. Before I continue on, we've got a couple of useful things we know just by looking at this equation. I know that my slope, when looking at an equation in standard form, is the opposite of a divided by b. So that means my slope in this equation is the opposite of 3 divided by negative 6. The two negatives cancel, and my fraction reduces to 1/2. So the slope is 1/2. Now what does that mean, slope? Well, think of slope as rate of change. And it'll make a lot more sense if we look at it on a graph. But before we can do that, we'll need to know a couple of points that the line passes through. Since the x-intercept occurs at y equals 0, I can easily use my standard form equation to find its location by plugging in 0 for y. Negative 6 times 0 is 0, leaving me with 3x equals 12, or x equals 4. Since the y-intercept occurs at x equals 0, I can find its location by substituting 0 with x. 3 times 0 is 0, leaving negative 6y equals 12, and y equals negative 2. Now we're ready to take this equation to a graph. The y-intercept is at 0, negative 2, and the x-intercept is at 4, 0. By connecting those 2 points with a line and extending it, I've got the shape of the graph. But what about the slope? Well, as stated in class, the slope, or the rate of change of a graph, or linear equation, is the change in y divided by the change in x. In this case, we know that's 1/2, which means that anytime we head up 1 unit on our graph, we head over 2. And the ratio will always be the same. If we head up 2, then to keep with the pattern, we need to head over 4. If we go up 3, then we go over 6. This is what it means to have a slope of 1/2. The ratio of the change in y to the change in x is always the same. This is just as obvious in a table of values. But to create a table, we're better off looking at the slope-intercept form. You know you're in slope-intercept form if you've got y alone on one side of the equal sign and something times x plus something else on the other. To get there, let's take the same equation but continue solving for y. Start by subtracting 3x from both sides. On the left, the positive 3x and the negative 3x cancel, leaving us with negative 6y. And on the right, we're left with 12 minus 3x. The next step is to divide each term in the equation by negative 6. The negative 6 divided by negative 6 on the left cancels, leaving only y. 12 divided by negative 6 is negative 2. And negative 3 divided by negative 6 is positive 1/2. And the x comes along for the ride. We're not in slope-intercept form yet, but we're close. Take a look at the equation when I highlight it in color. The slope, or value of m, is in blue. The y-intercept, or value of b, is in purple. So to get to proper slope-intercept form, we'll have to change the order of our terms. There. That's slope-intercept form. Note how the slope and the y-intercept are the same as when we were using standard form. Sketching a graph from slope-intercept form can be very instructive. We know the y-intercept is at negative 2, so I locate negative 2 on the y-axis and plot my point. Now I can use the slope to create the rest of the line. Up 1 over 2. Up 1 over 2. Up 1 over 2. I can also run the process backwards. Back 2, down 1. Back 2, down 1. Each of these will be points on the line, and we really only need 2. But what about that table of values? Well, we can choose any value we want for x, but with a linear equation, between -2 and +2 is usually okay. So we evaluate the function at our chosen values of x to determine our outputs at the values of y. And now let's look at our rates of change in the table. X is increasing by 1 each time because we chose for it to. And when we made that choice, the result was an increase in y by 1/2. Now note how the rate of change in x and the rate of change in y, while not the same, are both constant. So we can say that as x increases by 1, y increases by 1/2. Notice the similarities in the slope and the rate at which y is increasing relative to x. They're the same, and they follow the pattern from earlier. So let's review. We've got two forms of linear equations, standard and slope-intercept. Two different ways to write the equation of a line. Each comes with it a way of identifying the slope and a way of identifying intercepts. Standard form is probably more useful when attempting to identify X and Y-intercepts, while slope-intercept form is probably more useful when attempting to build a graph or a table. In both cases, the slope is readily identifiable. If you can put an equation into one of these two forms, you'll know that it's linear. If you're looking at a graph, you'll know it's a linear function if the graph is a line, horizontal, vertical, diagonal, sloping upwards or sloping downwards. If the graph is a line, you've got a linear function. You can also quickly identify the X and Y-intercepts by locating the points at which the line intersects either the X or the Y axis. The Y-intercept will always be located where X is equal to 0, and the X-intercept will always be located where Y is equal to 0. You can count the slope off a graph by analyzing the ratio of change in Y to change in X. As Y increases or decreases by some amount, X will increase or decrease by some amount. So the slope is the ratio of the change in Y to the change in X. Exactly when the slope of a line is positive and when the slope of a line is negative will become clear with practice. And finally, we have the table. When looking at a linear function, it's usually good to choose values between -2 and +2. Now that's not always true. It depends on the circumstance of the problem. But if you don't have any other information to go off of, it's a good place to start. You'll know you're dealing with a linear function if both x and y are increasing at a constant rate. Furthermore, you'll be able to determine your slope by evaluating the ratio of your change in y and your change in x, or in other words, by dividing the change in y by the change in x. In this case, it's 5. And last but not least, if you take nothing else away from this video, take away this fact. Slope is rate of change. That's a fact that remains important all the way up through calculus. Here's why. Suppose for a moment you have a curve, and you want to know how steep it is at any given point. Well, it turns out that the steepness, or the rate of change, of that curve at that point is equivalent to the slope of a line tangent to that curve at that point. This is important because curves don't deal in constant rates of change. Curves deal in changing rates of change. And if you aren't comfortable dealing with constant rates of change, dealing with the slope of a line, then you won't be able to deal with changing rates of change, slopes of curves. This should also help you understand why slope is called slope. Curves or hills have slopes in very noticeable ways, much more so than lines, but we can use lines to talk about the steepness or the slopes of curves at various locations in time and space. If you made it this far in the video, I'm going to give you a chance to get a little bit of free extra credit on Friday's quiz. So remember this, the video bonus word is calculus.